Hey everybody, my name is Jonathan Helm, and in this video I'll show you how to calculate power for a one sample t-test and an independent samples t-test. So I already have R open, and we'll calculate power for t-tests in R. There's actually a lot of different ways that we can do this in R. But I think the simplest package to use is one that's called PWR for power. So if you don't have this package already, then you'll go ahead and use the install.packages function. Okay, and so you can highlight and run that code. Make sure that PWR is in quotes. Okay, I already have it, so I'm not going to install the package, but we do need to use the library function. So even if you install the package, you'll have to use the library function to open that package up and make the functions inside that package available. There's a few different built-in functions in the power package, but there's one specifically for t-tests. So we'll look at calculating power using the power.t.test function. So I'll type power.t.test. There's a few arguments that you can insert, so you can say n equals t equals sig.level equals and power equals and type equals. Okay, so let's say that a researcher wants to calculate power. So imagine a researcher wants to calculate power. The researcher wants to perform a one sample t-test. She's going to collect data from, let's say she just gets data from 40 people, right? So her sample size is going to be 40. She expects an effect size equal to 0.25. She's going to choose an alpha level of 0.05. And of course, she's going to use a one sample t-test. So what we can do is we can plug this information into this function. So we have n is equal to 40. Okay, so in the function, it's a lowercase n, even though I've typed uppercase n up here. Right, so we have a 40. We have our effect size of 0.25. Our significance level represents our alpha. So remember that in science, we almost always choose 0.05. Power is something that we want to calculate, so we're not actually going to give the function power. Instead, we can write this word null in capital letters, okay, which is another way of communicating to R that we'd like to just leave it blank. So the function won't actually gain any information when we type the word null in here, but we do have to put the word null so that R knows that we intended to leave it blank. And then for type, we can put one sample. So in quotes, one dot sample. So if I highlight and run this code, and I'm going to get some output back, you'll see that's here. So I'm just going to copy this, and I'll paste it into here. I'm going to comment all of it out so we know that it's output. And what you can see is that, right, so it's gonna echo back the sample size that you inserted. It'll echo back the effect size, alpha level, and what it's going to do, it's going to calculate power for you. So it'll return that estimate of power for you. So if this researcher wants to perform a one sample t-test, right, with a significance level of 0.05, effect size of 0.25, and a sample size of 40, and she has about a 0.34 chance of detecting that effect, right? So if she did this 100 times, then we would expect 34 of those times that she would get a significant result. So this is an example of if that researcher wanted to calculate power. Let's say, on the other hand, so I'm just going to copy this, put this down here. Let's say that the researcher wants to calculate a sample size. Right. And so what that means is that I no longer have this sample size here, so I'm going to remove it, but what I do have is a power. So let's say that the researcher wants power to equal 0.9. Let me grab this code up here for the power t-test. I'll just paste this in here. So now for this one, right, I want to calculate sample size. So I'm going to remove 40 and I'll type the word null in all capital letters here. I still have my effect size of 0.25, my significance level is 0.05, and now my power is equal to 0.90. So we're asking a different question. We're saying, well, if we want power to be 90%, and I have this effect size and the significance level, then what's the sample size I need to be able to detect that effect with 90% power? So if I highlight and I run that, I'll get some output. And I'm just going to copy and paste this. I'll comment all of it out so we know that it's output. And so you'll see that, again, what we have from the function is being matched by the output, right? So our d is 0.25, our significance level is 0.05, power is 0.9. Right? But we left out the sample size, and so it's going to return to us 170. And remember that we should always round up. Okay, so this is the exact power calculation. So if I wanted to get exactly 90% power, then I would need 170.0511 people. Of course, it's impossible to have 170.05 people, so instead we will round up to get to our power. So I would need 171 people in this example. Now let's say a researcher wanted to do a two-sample t-test, so an independent samples t-test. So I want to do an independent samples t-test, two-sample t-test, and let's say I wanted to have power that's equal to 0.7. Say I wanted an effect size of 0.5, alpha is 0.05. So I'm going to grab the code up here. And for this example, we'll be calculating the sample size. The only thing I'm going to change is this one down here. So where we have type, instead of having one sample, I'll have a two-sample. And so I'll insert power of equal to 0.7. I'll insert a d of 0.5. And highlight and run this. We get some output back, and you'll notice that the output is very specific, that our sample size that we've returned is actually the number that we have for each of the groups. So going through this in a little bit more detail, right, we left n as null, we wanted to estimate that, so we got an estimated sample size. We see that our effect size is reproduced, the significance level, and the power are all reproduced. But we have this little note at the bottom which is saying n is the number in each group. Okay, so in each group. So that means I need 50.35363 people in each of my two samples in order to be able to detect this effect with 70% power. Okay, so that means is that I need 51 people per group. Remember, we're always rounding up. 51 people per group, or you can say that you need 102 people total. Okay, so that's how you calculate power for t-tests. If you look a little further, you can do dependent samples t-test. There's a paired option that we didn't get into. But just for looking at the one sample or two sample or independent sample t-test, this is the code that we can use in R. Thanks so much for watching.